Okay, good day, panel and fellow students. I'm Kotze, and I'm going to present to you my industrial automation and coding project.
A double win.
My problem statement is to design and implement a water flocculant system that automatically fill a water tank. Apply flocculant chemicals and transfer clean water to a secondary tank, controlled via mobile application transmitted through a wireless home network. Now I'm just going to explain to you how my project works, the process, what it follows, so it can be more understandable further in the presentation. So firstly, we pump the water out of a canal into what I call the dirty tank. And then we pour chemicals in and let it circulate for a certain amount of time. And then let it settle and then transfer that clean water to a clean tank for house use. This is just the communication between my devices. I used a logo and a Arduino Mega with Wi-Fi. So the logo talks to the Arduino through digital pins. And the reason why I used the Arduino as well is because I had to have 9 outputs and the logo only provides 4. So I had to find a way to extend my output range, which I will explain later on. And then on the board itself, there's a Mega and an ESP8266, and they communicate through serial. And then the app communicates with the Arduino board with Wi-Fi UDP connection, which I will explain later as well. This is just an AutoCAD drawing of my tank's layout and my valves and my pumps. So in the red, it is the float switches, that's my inputs. And tank 3 is the dirty tank, which I will fill with dirty water. And the tank 1 and 2 is seen as one tank because it provides me with a redundancy water after if the canal is being serviced or cleaned or there's not water available to fill and keep the cycle going. I've done some research on the Wi-Fi connectivity, and what I've found, I required my networking skills, my knowledge on it, and searched for TCP connections because according to me, it's a better connection because it's established the connection first and then transfer the data. But it turns out to be very complicated implementing it on the Arduino and the B4A. So I found out that Arduinos can create web servers and the app can connect to the web server and manipulate the buttons. And that's an example of a web server. But there was quite a substantial lag between the web server and the Arduino itself. So I just went and looked for more information on UDP connections and found some, and the UDP stands for User Datagram Protocol. It turns out to be much more easier to implement, lesser libraries to use. It was just, the code was much more easier to understand. So this is my B4A, that is the coding 1 course. B4A stands for Basic for Android, and on the left hand side is my background of my app, and the middle one is my icon. So if you go into the app, this is the display you'll see. And if we go and click on the start button, before we click the start button, at the top it says the system is in, so it will say in running mode or in stop mode, and this image displays as it's in stop mode. So if we click the start button, the display changes to this and 2 buttons appear. And the system icon changes to running. And the system, it says that the system is in start process mode. So if we click on the 15-minute button, it will change the display again, and it will trigger a command. But before we do that, I just want to show that there's an emergency stop button, which can be pressed at any time to interrupt the process. So let's click the 15 minutes, and that the display changes again, and a stop button appears. That stop button is to stop the transferring mode. This transferring is not transferring from the dirty tank to the clean tank. This is transferring clean water to a secondary house with a smaller tank. And I'm using the timer because I can't put in a float switch because the destination of the house is too far from the tank's location. So if you click the stop button, a message box appears and it says the transfer is stopped. So we say okay, and it says the system is in a transfer stopped mode. And let me just demonstrate what happens if you press the emergency stop. It stops the whole process. You can see the image change to the system is not running. It says the system is an emergency stop, and the process period is an error. So the transferring period is an error, so it can't be transferred. Now I'm just going to show you a bit of code and my visual designer. This is the visual designer where you can plot your buttons and give them purposes, I would like to call it. You can give it a click, a long click, or a double click for that matter. And you can put on displays for labels and images, and even set the background as I did. This is the UDP code that I found. There's a UDP packet send arrive sub and a UDP packet send sub. And that subs are used to send the information from the app to the Arduino. This is code of the start and stop button, the emergency stop button. And if I press the button, this is the sub that will be activated. And if this is activated, the code in that button will be run. And I will just explain the first line. If the BTN stands for button, but the button 15 min is the 15-minute button. Dot visible is stated that it is visible or not, and the true or false will state is it visible or not. So in this case, the button will appear, and the next line says that the start button will disappear. And further in the code, it says st send, that is a string, and next to it, it says start process. And that is the key word that I send to the Arduino, and that will set in motion a set of if statements. And just to send that string, we need to call that sub that I explained, the packet send sub, UDP packet send. This is my logo code. It is quite busy. This is the full page of the logo that is provided. So every code that you need to write can be done on this, only this sheet. You can extend it and link sheets together, but it's a bit complicated to do that. So let me show you a small snip of this code. The filling stage is the first stage. It depends on what is the state of the tank. If the dirty tank is full, the filling sequence will not take place and the transferring sequence will take place. But if the tank is empty, this is how the sequence will start. So on my app, I press the start button and this I input will be activated and will go through a series of AND gates or OR gates, and this will determine if the latching relay will be activated. The latching relay is only there to keep the step in motion even though the input is deactivated. And it will be resetted after the next stage after the stage has been started. So the next sequence is the circulation sequence and the settling sequence and the ready for transfer sequence. They all work with the same foundation, has AND and OR gates to set and reset the latching relay, and has flags and have message boxes to identify in which step it is. And if it gets to the ready for transfer, which is the bottom part here, the program will look at the input 4, which is the low level of the 2 tanks, the clean tanks. And if it's not below that level, it will not transfer the clean water and will wait until the level has been reached. So this is how I extended my output range. So I used a combination of 1 to 4 of outputs. So this is the list of the steps I have. So let's take, for example, the first one, output 1 is on, and it says it's the filling step. So the binary would be 0, 0, 1. But after a while, I used output 1 again, and I used it in the transferring end. And output 1, 2, and 3 is on. And that is the binary of 0, 1, 1, 1. And that triggers a different step. And that's where the Arduino came in, to extend my output range. So this is just a bill of materials of some of the stuff I used. Most of the stuff I repurposed, like the 1,000-liter tanks. I repurposed wire, valves, mechanical valves, and pipework and keys, and I repurposed most of the stuff. But I did bought new AC solenoid valves. I bought 5-volt relays. The PLC was provided. I got an Arduino Mega. So I've mostly reused for this project. Things that I've learned is I've learned how to function block programming, B4A coding, 3-phase electrical wiring, panel wiring, and I revised my Arduino programming, which was very fun. PPD, didn't have an official PPD this term, but I went to a workplace to do my studies because I was studying from remotely. And I really used my previous PPD skills to fluence in the workspace. What I struggled with was I had too little outputs, so I had to find a way to extend them. The Wi-Fi connection between the app and Arduino was quite difficult. It took me two weeks to figure that out, and it was quite difficult. Still struggling with some communication issues, but we'll sort them out quickly. Arduino code, I did do Arduino before, but I had to revise it because I did struggle with remembering some of the stuff. And the Arduino board itself, it's a new board and had to figure out the serial communication. But it's a very nice board and I'm looking forward in working with it again. My time management is, I give it an 8 out of 10. I planned my project week by week, and I would like to do that differently. What I would do differently is study at class, not remotely. It's really difficult. Communicating with the lecturers was difficult. There was a lot of communication issues, but we did figure that out soon and sorted that. Plan more in detail, not planning week by week, but more like day by day. If I have to finish something, it must be today, not at the end of the week. Otherwise, I leave too much stuff for the weekend. And my time management, I would like to improve. Thank you very much.